Hey guys, it's Rob here. So for those who haven't seen it, the Beaver, Utah UFO video was shot by a couple of drone operators that were flying their drone and caught what looks like an object traveling from a hillside about 2 miles away and flying past the drone at great speed. So it caused quite a stir, and I found it compelling myself. I also happened to notice an effect called parallax, which many of you may know about, and it's the way stationary objects move in the frame. And so I used that to try and establish that this object was really way back in the distance because it doesn't move with the foreground. And I thought that that was going to be proof, but because it is not a stationary object and it is moving, it just is another thing to consider. So like everybody else, I wanted to consider other things and try to use the parallax along with other considerations to determine what this object was. So I had an opportunity to look at another video. This one was from Rioja, Spain. And in this drone video, a similar thing happens where we get an object that flies past the drone. This one doesn't fly past quite so fast, but it was referred to me because it looks so similar, and I had some interesting ideas about what was going on with the Utah video. So one of the things that I want to point out is that this video is similar, but it's not in some ways. And first thing to note is that the field of view of this camera is different. It's a wider field of view, and because it is, it distorts how we perceive depth a little bit. So for instance, I'm just going to show you some different fields of view. The first one here, this 40-degree field of view, is the way the Utah UFO drone viewed the landscape. It was a 40-degree field of view. And that is closer to what we see with our eye. And 78 is actually what this drone is using, 78-degree field of view. So I've got 90 degrees up here because that's actually what I'm going to be showing you in a minute. That's what my GoPro can see. So I'll just move that for now. But the difference in the field of view is how much it compresses distances, how much it compresses what's in the frame. So these two are actually quite different. Well, you might say, well, what effect can that have? Why do we care about the field of view? Well, one of the things that people talk about is how fast things look like they're going, and sometimes they look like they come out of nowhere. Speaking of coming out of nowhere, here's another piece of footage off of YouTube where the drone operator says these birds come out of nowhere, and they happen to be shooting with the same 78-degree field of view on a Mavic Pro drone. So they do look like they come out of nowhere, but the reason that's the case is because the field of view is so large and it's being compressed, and so things aren't as far away as they seem, but because there's so much information being squeezed into this frame, things get tiny really fast, and they're not able to be rendered. We only have what equates to about a 2 megapixel image. So they do look like they're coming out of nowhere. But in reality, it's just a distortion of the lens. So comparing that to the Rioja, Spain video, what would that look like if it was shot with the drone from Beaver, Utah? So it would look more like this. You can see the difference. It's quite substantial. If you were using a 40-degree versus a 78, you get a wider field of view, you get more information, but also the details get smaller. Now, there's a little motion blur happening here, so don't judge the details, but look at the size of objects in the frame. And you can tell how one would make things look a lot closer and a lot more easy to see. And this is more how we would view with our eyes. And so here's another example using a practical target that I created. This is actually something that's 50 feet away, and it's shot using the same field of view, the 40 degrees, that you get from the Utah UFO video. So you can see here, a little bit difficult to see. I'll show you more clearly what those items are. But what if we were to back it up to 78? Wow, it's pretty substantial, the difference. You can see that the details drop off quite a bit. I'll just switch back and forth between the two. So I have even a third option for you to see the difference here, and this is my GoPro. there I am at the park, and I've set up my camera to take these pictures, and that's the 90-degree field of view from my GoPro. And you really can't even tell what's on the target there. So these are all important things to keep in mind when we're talking about this drone footage and analyzing objects in the frame. There's the two side by side, 40 degrees and 78. So it's important. It distorts the distance, even though this is the exact same distance, it distorts it when you have a wider field of view. So, well, there are a couple other differences with the Spain video, and people asked me to address those, and so that's another reason why I'm here. One of them is how fuzzy the edges are on the object. So as it gets closer to the lens, we expect to see motion blur on the forward and back side of it in the direction of motion, because it's obviously moving and somewhat quickly. But we don't expect to see the top and bottom edges fuzzy, and I addressed that in the review video for this La Rioja Spain video. And yet we see fuzzy edges, and that tends to happen whenever objects get close to the lens. As you can see, this lens has a long depth of field, because you want that when you're shooting landscape photography. But as you get closer to the lens, that sharpness drops off substantially. So that's why I determined this was probably a small object close to the frame, and I was asked to look at the same thing with the Utah video. One more small thing to point out, which we don't have it in the Utah video, but people have pointed it out and I just want to address it, is how the object looks like it curves up on its own. This could mean that it is something that's under its own control, but not necessarily. And I just want you guys to know about this for future reference. So let's take a look at graph paper here I have with my GoPro. Now we know this exaggerates the field of view, and it's not a rectilinear lens, which means you get kind of a fisheye effect. But that's what happens when you have a wide field of view. Even though it is corrected for, it's not always perfect. So what happens if you look at the way the lines move across this lens, you can see the distortion. But now we were talking about something that's traveling across the lens. So what if something is coming from the distance? So let me try to make that look a certain way for you so that we get lines coming from the distance. And hopefully you can see that is not a perfectly straight line. So something traveling straight at the camera would look as if it were going straight, but let's see if it is. As you can tell, that's a pretty good curve. So if we saw something coming from the distance flying straight at the camera, it would actually look like it was curving up. And I just want you to know that. So we looked at a lot of things with the Utah UFO video. One of the things, which was a great suggestion, is birds. So we looked at the gyrfalcon. This I really thought was the deal. It's a super fast bird. It's big. It's white, or it can be white, and it just seemed to make sense. But here's the problem. Unfortunately, the math doesn't work. You know, we try to say how far can this bird fly and what would it look like in the frame, and it would have to be going incredibly fast to be such a tiny dot in the frame and cross out of frame in only 1 second. And just in case you're not remembering what that would look like, here is the 1 second mark. So that's what this bird would look like 1 second from exiting frame. And that would have to be a really, really fast bird to be that small, you know, with a 50 millimeter equivalent lens, and then fly out of the frame. It has that look. It has an organic look to it. So we want to put those things in place. We want to make it look like something natural. And you know, I agree with testing those things. Here's another thing that was suggested. This one isn't a hawk, but it's a hawk moth. And that's a great thing to consider. They're super fast. They flap their wings super fast. And it also can come in a very light color that would reflect the sun. So that's super cool. So let's look at the shape. Does the shape that we get match? Well, I looped this shape. I looped the shape change, and it actually changes shape in such a way that it does look organic. It looks like something that would have wings. You know, this is from when it makes its bank turn to when it goes out of frame. And it does change shape. Now it could be rotating. It could be just a stationary object or a fixed object that's just rotating. But, you know, we have to consider these things. So you say, well, maybe that's, you know, maybe it's turning, but the flapping of the wings of the moth is just something that matches it matches the frame rate of the camera, which that can happen. You know, here's a good one of matching the frame rate of the camera. It makes things look stationary. I know you want to see that again, so I'm going to show you that again. Super cool. So, you know, you test those things and you see, does that seem like what we got here? So we put a moth in the frame, or a butterfly in this case, and you know, you can make a lot of things match. You certainly can make a butterfly match. There's the butterfly that we're using. It's got the wing flap, and the really cool thing about the wing flap is it can actually explain why it seems to disappear at times, is that when the wings are level, we don't have anything to reflect off of. So it doesn't reflect the light back. So something white like that does seem to make sense. The problem is even the smallest butterflies are still pretty sizable, and they just can't travel far enough, very fast, in order to be this, to match this. You know, it is interesting how this thing exits frame, and you might say, well, that's not the way a butterfly glides or a moth glides, but unfortunately, I have an example showing that it actually does just that. And here's another one. As you can see, I researched this stuff for you guys. You're tenacious. I got to have answers. So what else could we possibly consider? Is it something small and super fast that's reflecting light, like a horsefly or a bee? Well, yeah, they reflect light. They don't always have to look like bees when they're blurred out. But unfortunately, we still can't get that white color, and the shape just doesn't match. Even if the wings do seem to freeze frame based on the frame rate, we still can't get the right shape and the right color from something like a bee or even a horsefly. So, you know, I'm looking at this and I'm thinking, gosh, it's something that's coming from such a distance because parallax is saying that it's far away. And is there anything else it can be? What have I not looked at? Because, you know, so many people are looking to me for answers, and it's, you know, when you've got something that's unidentified and you're saying it's compelling, well, do you just stop there? So no, I don't stop there. I don't think you guys expect that from me. So I decided to turn things on their side and look at it another way. And I changed the color scheme here a bit so that I could try and erase the background as much as I could. I wanted to get rid of that perception of the background and just look at how things move in the frame. So one of the things that I did was I locked in with this first arrow on the bush that's in the foreground. And this particular bush here is the one that I matched up to. And I wanted to see when this object appears, which is right there, does it move in the up and down direction the same way that this that the foreground does? Because we checked it going horizontally, but not the vertical direction. So I just turned it on its side to see it differently. And one of the things I noticed was that if you look at how far this arrow has traveled from the original line and this arrow from the original line, it's pretty similar. So what does that tell me? It tells me that the drone, as it moves up the hill, is causing all of the landscape to drop. And so if this object is closer to the lens than we think, maybe it's not flying down the mountainside, maybe it's actually just dropping in elevation as perceived by the drone, because it's closer to the lens and the drone is actually moving up. So the object isn't going anywhere. So now what do we do? Well, we've got the parallax locking this item into the background, this object into the background at a certain point, but then at a certain point, it seems to be moving. And we were kind of deceived, possibly, you know, we're still investigating this, into seeing that object as flying down the hill and moving forward. But as I move the camera back and forth, the video back and forth, what if that object isn't actually moving forward very much? What if it's actually stationary? Have you noticed that it, again, if we use parallax, what is it tracking with now? Well, I wanted to see that a little bit better. So I decided to look at it another way. So I did another view of this, and I stabilized the foreground, and I stabilized it on this bush here. And I made this bush and the foreground stay, or this tree, stay the same size. So when I play this through, you may find it to be a little bit, throw you off just a little bit, but there's the playthrough of this, of stabilized version. And it gives us another way to look at it. And I know that's a little jarring to see what happens as this thing moves by, and I'm changing size, but let me get rid of this black border, size this up a little bit. There we go. So now let me go through this again, now that the foreground is staying in place. And as I just move back and forth through that, is it possible that this is a tiny object closer to the lens that's actually, I mean, if we just draw a line straight down onto the plateau here behind the tree, you know, into the grass, is it possible that this is something tiny that's sort of floating on the air? So now consider this. So what if the point where it looked like it was tracking with the background, it's actually moving straight towards the drone, and it's slowly going out of sync with the drone. So it's traveling towards the drone, but actually if you look at this tree here, it's traveling towards the tree. So match it up as if it were traveling towards the tree, and as the drone moves past the tree, you can see the object continues to move towards the tree. And it seems to, right before it banks, it seems to continue to follow that path, right? So that's kind of interesting. It can be moving a small amount closer to the lens and tracking towards the tree before it actually changes directions. Now, why is this different than a bug? Well, it's the only thing we didn't try. It's looking at something that's actually smaller than a bug. There was a problem, and this is why we didn't look at it, is a bug and things that are small are too small to see from a distance. Because you got to remember, this drone is traveling forward at 28 miles per hour or 41 feet per second. So in 1 second, this drone travels 41 feet. You know, that's going pretty fast. So it means that when we first see this thing way back on the hillside there, it's at least 41 feet away because it's a second away, but it's probably even further, right? Because it never reaches the drone. So in order for something to be visible that far away, it has to be relatively big, and a bug that far away is too small to see. Or is it? That's what we want to look at. What can we see something small that far away? So I think that's worth testing. And when I look at this new way of looking at the video, I wanted to see more. I wanted to see, can I see something really tiny that far away? So I made a target, and I'm back to the target you guys have seen before. Now this is at 10 feet away. This is a photograph of this target, and I'll give you a little bit better view of it. There it is there. And so this is just a reference target that I made to shoot with my camera. I've got 1 inch squares, 1/2 inch and 1/4 inch squares there. And then of course a 6 inch bar on the side. And down at the bottom, the 1, 1/2 and 1/4 inch squares in both black and white. And that's important. That's really gonna help us determine some new information here. So also on the top here, you can see that I've got a 3/8 of an inch white sphere, and which is a little bit smaller than the 1/2 inch squares. And then I have a 1.5 inch ping pong ball. So this is 1.5 inch ping pong ball. And that's obviously white, and that's gonna show up really good in the sun. So what did I do? Well, I took those things to the park, and I set up my camera at the park, and I set up a little scenario where I could change the focal length of my camera and get some example shots to show you guys. So the first thing I did was I actually took the target all the way back to 100 feet. So from 100 feet, I wanted to be able to show you, what this thing looked like. And that would be about what the drone could travel at in about 2 seconds. So here's my setup at 100 feet. And as you can see, that looks pretty good. That's pretty far away though. It's pretty cool how we've got some bugs in the frame. But that's that's the view at the equivalent field of view of what the drone shot for Beaver, Utah. And of course, when you look at it on the 90-degree field of view of my GoPro, you can see, wow, how that significantly changes how we can perceive that distance. A couple of cool things about these little bugs that fly through the lens that I want to show you, because I'm going to reference this. This first one is actually a beetle, and you can barely see it because the sun makes it bright against the grass. And I'm a tad overexposed here anyway. But as it flies out of frame, you can even see that rod effect where we get the doubling of the wings as it flies. But it flies out of frame down low here, and it kind of blurry and a little overexposed. But what if we looked at that? And let's go ahead and look at the butterfly as well. This is a butterfly. We have a migration of the I think they're painted lady butterflies. I think that's what they are. Thousands of them migrating, so you might see a few more in the frame. And this one actually looks like it comes right up to the lens. It flies right out, and it's pretty cool how that looks, almost like what things we've seen before, doesn't it? You can tell it's a butterfly. Actually, now I can recall this one is a monarch butterfly. It was pretty easy to see what it was in person there. So that's a monarch butterfly flying out of frame. And it's a pretty good size one too. So, well, what's interesting about this and what I wanted to show you was, what if we look at this on the other camera? If I look at this with the GoPro camera, what you'll see is, here's the first guy flying out of frame, and you really see a lot more. And you can also see it at 60 frames per second, whereas my camera was only shooting at 30 frames per second. So it looks quite a bit different. It still looks light colored because of the sun, but at certain spots you can tell that this is a dark insect, right? And as it travels out of frame, it goes so much further, and we see so much more on the GoPro. Well, I'm also interested in how it distorts what you can see. So this GoPro is just over my shoulder. Look at the butterfly this time. Here's the butterfly, and as you can see, it looks really far away just before it goes out of frame. There it is, and it just doesn't seem correct that is what we saw. And if you keep watching, you'll see right as it goes out this way, it looks really far from the frame. I mean, we know what that is now, but this is again the distortion of the wide-angle lens, making things look farther away than they really are. The interesting thing about that is that there's actually a shadow being cast by this, and you might be able to see it right down here. I've got it marked. I thought that was pretty cool, that it just shows you it really is a lot closer, but the view is distorted. So back to this footage. That's a good reference for us, and I can zoom in on that and show you that at 100 feet, you're not going to see a whole lot of detail. So this is zoomed in 800%. All right, I also shot this target at 50 feet. And 50 feet, it's nice to see that we do get a little bit more detail, and I can zoom in on that one as well. And now we can see some separation between the black and the white squares, and hardly can pick up those little 1/4-inch squares. I made the mistake of setting this up against the sidewalk here, but I can almost pick out the white, the 3/8 inch ball on that side, and then there's the ping pong ball. So I did set up one other test. I wanted to set up so that I was all the way backlit and run a test with something really small. So I like the small things that I have on the target, but it's really hard to get the effect of being backlit by the sun with the paper target. So I tried something a little bit different. I cut a small piece of feather and tied it to a weight, a little steel ring, so that I could put this tiny little feather in front of the camera. And if you average it out, it's about 1/8 of an inch. I hope you can tell there. So what I did though was I also wanted to exaggerate the field of view just a little bit, And instead of shooting at this field of view, which is equivalent to what the drone footage was shot at, I actually shot it wider at about 28 millimeters. Whenever I do that, you get something that looks more like this. So as you can tell, that's exaggerated quite a bit, how far and how small things are going to be. So now, if I can see something that far down that's small and white, that tells me that it is possible for something really tiny and really reflective or bright to be within 1 second's range of the drone. So I tested that. So I took my white feather and even put a butterfly on there because we were still considering the whole butterfly, dark and light colored, and I ran through it. So this is me walking all the way down. There's 40 feet. Pretty cool. There we got 4 feet, 8 feet. I'm calling them out, and although you guys can't hear it. And there's 10 feet. You got to make the butterflies fly, of course. There's 20 feet. Don't worry, I'm going to pause here in just a second because I do have something I want to show you. But I want to wait until we get all the way down to the end, right there. Now, I was pretty impressed by this. Now, this is a wider angle. This is a tiny little 1/8 of an inch. It's 50 feet away. And let me zoom in for you guys here. Can you see that? Well, that was pretty special to me because that let me know that you can actually see something tiny that's far away because of, and we got some bug friends too, because of something called diffraction. What's happening is the bright sun is causing a blooming effect on this tiny object because light is being diffracted in multiple directions, and that's picked up by the camera. Now we can especially see that because it's against a dark background, and we have that same effect in the Beaver, Utah video. It's not necessary for it to be against a dark background for us to still see it, but it's a lot harder for us to perceive it when it's not against the dark background. So the fact that I could see that, and by the way, we're zoomed in here almost 700% so that we could see that. And if you look at the board, I just want to call your attention to this. There's a 1/4 of an inch dot somewhere over there that's white that you really can't even see, right? And there's the 1/2 inch that looks about like the 1/8 of an inch fuzzy thing that we're taking a picture of here. But things are so blurred out because it doesn't resolve at the distance, but yet we can still see it. And so this is a real world practical test that helps us learn how to analyze these things in the future. You know, logic tells us we wouldn't be able to see it. We can't see a bug that far. Look, if we had a dark colored bug, it would barely be perceptible, right? But the light reflecting off of it makes it diffract and therefore makes it more visible. I also want to point out our butterfly here. Why is the butterfly not a good example? Well, because look how large it is. We need that butterfly to be, 4 times smaller in order for it to be to match the video. But yet it's just too big in the frame. So that's why it can't be a butterfly that we're seeing. It has to be something really tiny. I'm not saying that it's not supernatural. I'm not saying that it's not still a bug of some sort. What I'm saying is that it has to be, in this test, it has to be something tiny. And I'm able to see that. So that's really important. So there's our object, really, really tiny. Again, we're looking at the distorted view, right? And so you have to say, does this thing look like something that might be, closer to the lens, right? Closer to the lens. And how would it go past the camera? If it wasn't a bug or something flying, then how would it actually move past the camera? Well, I actually looked into the weather. I checked the weather for the time that they were there. It was in 2016. I think it was October 17th. It was 16th or 17th, but the weather was the same for both days. And you may be surprised to know that the wind was really high. 39 was the max wind speed from one website. Farmer's Almanac, checking for the same date, had a little bit more detail. Average wind speed of 23 and a sustained wind. That means something that blows for more than a few seconds of almost 37 miles per hour. I mean, that's really significant. That's not just a casual walk in the park day there. That's a lot of wind. And then 50 mile per hour gust. That's like being on the highway. So, that's a lot of wind. And these guys said that they had a headwind. I believe in one interview they mentioned there being about 17 to 20 mile per hour that they noticed. And if it was a headwind, that means that the drone was flying into it. And yes, it could cause things to fly towards the drone. So it doesn't mean it has to be something that was navigating on its own. Now, again, this is me investigating possibilities. I'm not telling you what this was. I don't know what it was. So this is possibilities. So are there any, things that could occur in nature that would match something that would be able to just float in the air like that and be blown towards the camera? Well, this guy says there probably is. And as we know, there's some of those guys around, and there's some of this stuff around. The aspen, the poplar, and the cottonwood trees all have some pretty cool stuff. I'm sure you guys have seen that before. Here's another view of something like that. It just floats in the air. Now, am I saying that's what it is? I don't know. I mean, spiderweb even floats in the air. It's pretty cool how these things happen in nature. So I'm not saying that's what it is. I just think that it's neat that we've looked at this another way and we found another possible explanation for how something like that could occur. Does it mean that it's not a craft traveling 9,000 miles per hour? Of course it doesn't. So in the end, I just want to say, I think we've shown that there is another possibility that we have to consider, that this is something really tiny and really close to the lens. Looking at it in slow motion, it does seem to have a cinematic effect to it, but when you look at it at real speed, I think it is possible that this is much closer. We would be able to see it because it's bright white and it blows past the lens with the wind in the air. Now, it doesn't mean that that's what I think it is. It just means that that is a possibility that I find hard to rule out right now. It is something that is organic. It changes shape. So it does tend to say maybe this isn't a fixed structural craft that's flying by. But honestly, I remain compelled by this video, and I will consider it forever one of my top videos to reference. So thanks. Until next time, this is Rob, and we'll see you on the internet.